Dear students, today we'll learn remaining instructions from the group data transfer instructions group. After learning that MOV, MVI, LXI, XAJ instruction, there are a few more instructions from the group number 1 data transfer group of instructions. Here it is LDA. It's the 3-byte instruction. 3-byte means it needs 3 locations in the program table and which containing the operand of 16-bit or 2-byte. Here L is here to load. A is here accumulator. To load accumulator with content of any location or load accumulator with any memory location content. As an example, LDA is the instruction or mnemonic and 7050 is here 16-bit operand because of it is treated as a 3-byte instruction. If we have 7050 content as a 3C, 7050 is the memory location in the memory IC where content is 3C. After the instruction execution LDA 7050, if previous content of A is 02, it will be replaced by this memory content and it will show us output in accumulator is 3C instead of 02. So this is the instruction LDA to load any memory location content directly for accumulator. After this, we'll go for the next instruction. Here it is STA. STA is a 3-byte instruction. ST is here to store. A is for accumulator. It is used to store accumulator on any memory location. Reverse transfer of this, here it is, we are taking from memory to accumulator. Here we are transferring accumulator to memory. Example how it can be written: STA 8000 is 8000 operand is 2-byte or 16-bit in binary. That's why it is 3-byte instruction. If A is containing A9, memory location 8000 contains some content 00. After the instruction execution STA 8000, content of A as it is can be transferred for the location 8000. So as an output, it can show us A9 on this location 8000 instead of 00. So these are two instructions, LDA, STA, to load accumulator from the location, and this is to transfer accumulator on location. After this, we'll go for the instruction. Another way is there to load content of any location from any memory location using the instruction. Here it is LDAX. Instruction LDAX is 1 byte. LDX is 1 byte. It is useful to load accumulator with the content of location initialized by HL pair. Means whenever there is X in the instruction, there is a register pair. So here though is a H is written indirectly, we have to consider L also. So this instruction LDX is useful to load content of any location, and that location which gets initialized by any register pair, either HL, DE or BC. LDXD instruction comment is load accumulator with the content of location initialized by DE pair. And for LDXB, the comment is load accumulator with the content of location initialized by B for BC pair. BC pair. Example, if on this location 6050 content is B2, using the instruction LXI H6050, it will point the memory location 6050 where the B2 is there by loading content in H60 and in L50. the memory pointer will be here on this location 6050. And after this instruction, if I use LDAX H, here H means HL pair should be there used. So the location initialized by HL pair is 6050, and that is to load accumulator with the content of location initialized by HL pair. This B2 content will be shifted for accumulator if A content is 0, 1, some previous content as an output. Instead of this 0, 1, the new content will be here B2 after instruction execution of these two instructions. Clear to you? Now, after this, the next instruction is here STX. STX instruction is ST is to store. ST means to store. 1 byte instruction. It is to store accumulator on location that is initialized by any register pair. If I write STXD, it will store accumulator on the location that is initialized by a DE pair. STXH means store accumulator on the location initialized by HL pair, and STXB means it will store accumulator on the location initialized by BC pair. Example here is LXI B7050. It will load in B70 and in C 50 to show memory pointer on 7050 location which is initialized, where the content is here C2. If I write STXB, it means to store accumulator on the location initialized by BC pair. BC pair initialize the location 7050. Content of A will be shifted as it is on this location. So as an output, instead of C2, we can observe 0F as a new content. So these are the ways to transfer content of location in the accumulator or to transfer content of accumulator on any location. Next instruction is here IN. First of all, consider here, this is our microcomputer system which is where there is a 8085 microprocessor which contains accumulator as a one of the register 8-bit, and these are the ports. These are the ports. Port is nothing but the part of the microcomputer to take data in the system to send data out of the system. And this is the nothing but another digital system that is as an outside system. This is outside digital system which is interfaced with microcomputer system with the help of ports. Port is nothing but the part of microcomputer to take in and to send out the data in between these two systems. So IN is the instruction 2 byte. IN is to take in data from outside system in accumulator. If I write IN02, its comment is receive data in accumulator from outside system via port number 02. 02 is not a data, but it is a port number through which data can be taken in. So there are 8085 contains 256 number of ports with port addresses. 02 is nothing but port address through which data can be taken in. The port addresses are 002FF. So from any one port of this 256, data can be taken in accumulator, from outside system only in accumulator. Similarly, to send out data, instruction is out, and that is 2-word instruction to send out data only of accumulator for outside system via port. If I write out 0D, 0D is nothing but a data byte, but it is a port address. So comment is transfer accumulator content for outside system via port number 0D. Like this 02, this 0D is also one of the port here which is on the microcomputer system to send out data, or via 0D port number also data can be taken in. On which port that system is interfaced connected, only that port number should be taken to send data out or to take data in between accumulator and outside system directly. So these are the today's instructions. We learned LDA, STA, LDAX, STX. These 4 instructions are to transfer data in between any memory location and accumulator. And we learn also this instruction in and out to take data in, out to send out between accumulator and outside digital system which is connected to a particular port number which are out of 256. That's it. Thank you.